Okay, good morning everyone. We'll make a start. So my lecture this week carries on fairly directly from the one I gave last week. So this week we'll be looking at the dynamic web, so what it actually is and ultimately why we need it. So first a little recap from last week, some of the things that we learned. Basically we looked at the history of the internet and the World Wide Web, and we discovered some trends that seem to have been occurring and continue to occur. And some of those trends included the fact that there was lots more content more frequently, so both more frequently up-to-date content and more frequently on demand, from more different sources. Okay, so including not only sources traditionally driven one way, we're also getting user-created content coming back the other way, and on more devices. So I've got just a few scenarios that I want you to imagine as if you had to do these with only static website technology. Okay, so the first one's one that you're probably already familiar with. So let's say a client asks you to create a 10-page site with a main menu, and so there's 10 menu item links which link to each of those 10 pages. And then at some point later on they go, oh, can we add an extra menu item please? So you go, okay, well I'll go back through all of my 10 pages and I'll find the code that I've duplicated across each of those pages containing the menu, and I'll add a new list item with a new link that links to the new page, and then I'll duplicate that across my 10 pages. So it's a little bit annoying, but it's doable. But then imagine now that's 100 pages or then 1,000 pages. So as you start to see the volume of content becomes more, you have sites that have much more content, it sort of goes from being a bit of an annoyance to something that's just actually sort of infeasible to do in that fashion. Okay, and then imagine that you're trying to run Wikipedia as a static website. Okay, and let's say you need to change one of the URLs of one of the articles. Okay, so, or you need to change the file name of that HTML file, and therefore the URL pointing to that file is going to change. But in Wikipedia, there's articles linking in between other articles, so you might have dozens, hundreds, thousands of other articles that all link back to this one. So then you need to go through and find all of those other pages which link back to this, and then update those links as well. Okay, and then finally, imagine that you're trying to run YouTube as a static website. Okay, so first of all, you have to figure out how to actually get the videos. Okay, because there's no dynamic way of actually uploading files. Maybe you have an FTP site where people upload them, or maybe they email you video, maybe they actually post it in the mail, and then you have to take all of those, manually collate those, and then publish those on static web pages. Okay, so when you consider how many videos there are actually on YouTube, I think it's something like a day's worth of video is actually published every hour on YouTube. You can see that I mean, you could take all the manpower in the world, and that's still not feasible to operate that as a static website. Okay, so on that point, here are just some stats about the amount of web content that goes around. So as I just said, 24 hours of video is uploaded to YouTube every minute. And since I originally posted that, I think that's gone up to like 36 hours and just keeps going up. So I think I incorrectly said every day. So it's actually a day's worth of content goes up every minute onto YouTube. More than 30 billion pieces of web content, okay, of various kinds are shared each month in over 70 different languages. So that's another thing that we haven't actually even considered. What happens when we need to translate our content to all these different languages? Do we duplicate our 10 pages 70 different times across all of those languages, and then have to go and edit all of those when we make edits? Okay, and 50 million tweets are sent per day. Okay, again, these stats are a couple of years old now, but you can assume that they've only gone up. So I think we can agree that it's pretty clear that the static model of websites is untenable in this modern web environment. Okay, so you'll actually find that the amount of scenarios where creating a static website like you might have been used to doing thus far actually become very few. I'm not saying there's no No scenarios where it's not still useful to do that. Maybe you do have a small website that only has a few pages and you can be confident that the content's not going to change very much. In that case, it may be easier, more time effective just to do a static website. But I challenge you to find any popular or large website on the internet now that actually operates as a static website. So this is where dynamic web technologies come to the rescue. Okay, they provide us all of these extra things that allow us to deal with these crazy amounts of content, crazy amounts of users, okay, and all of these other demands. So what kind of things can we do with dynamic web technology? Okay, so a bunch is the answer, but these are just some examples. So we can automate repetitive tasks. Okay, so in the case of YouTube, we can create an interface that accepts the video uploads and then actually, without anyone touching it, sends them off to be processed into the correct format to YouTube, and then when that's done, automatically publishes them. Okay, and in a scenario where that much content, that much video content is being published to YouTube, that's the only way to do it, is to automate those tasks. Okay, we can do calculations. It seems simple, but it's something we can't do in a static website. We can access dynamic information, for example, the current date and time. Okay, again, something that we can't do just with HTML. We can handle input, okay, which is very important. So at the moment with static web pages, we're used to pretty much one-way communication. I request a web page from the web server and it sends back the content. Okay, but as soon as we add dynamic technologies into the mix, we can all of a sudden now take user input, okay, along with the request for the web page, and we can use that to modify the output. So that input might be things such as forms, it might be things such as file uploads, or really any other kind of input that you can think of. And also it allows us to separate our content from our markup. So that's an extra level of separation of all the bits that go together to making up our website. And I'll explain more later on why that's important. So dynamic web technologies are effective ninjas. And what I mean by that is, to the end user, there's really nothing or not very much that indicates whether you're browsing a static or a dynamic website. Okay, and that's actually a good thing. You don't want the end user to have to suddenly operate the internet differently from using a static website to a dynamic website. So that's one of the reasons why it can be a little bit more difficult to understand what's going on, because the difference is not very transparent there from an end user point of view. So, but that's the whole idea. We make the end user experience the same, but we sort of, as designers and developers, we put more effort into understanding and developing our side of things so that the end user result is seamless or very much the same. So I'm going to start talking about the client-server model. So it's possible to get quite a long way into web design and web development without really having an appreciation for what's going on behind the screen. And so often we think of, basically, there's our computer screen there, we're requesting a website from the web browser, it goes away to this magic cloud somewhere and comes back with the website. And that's fine, you can abstract what's going on there like that, but I think having some understanding of actually what's going on behind the scenes there, from both like a hardware and a networking level, and also from a software and protocol level, can help sort of give you a better appreciation for how the dynamic web technologies that we're going to implement actually work. So I don't expect that you necessarily need to remember much of this stuff in detail, unless you want to go on to be network engineers or something. But having some sort of understanding of this, I think, should be useful. So it's also useful, I think, to actually be able to physically see what the internet looks like. Okay, again, to dispel the conception that the internet is just some magic cloud that, you know, does magical stuff that no one understands and then gives you your content. That's a fine conception for an end user to have because they don't care, they just want their content. But as someone who's actually working with it, it makes it less scary and less mystical if I think we can actually see what it looks like. So these next few slides are just some diagrams and pictures of what the actual hardware that goes into running the internet looks like. So this is a diagram of undersea fiber optic cables connecting all the different continents. So these are just the major communications backbones between the continents. So I guess the first thing to know is that the information has to travel along somewhere. Okay, it might seem simple to state, it's often overlooked. Okay, there has to be a connection, whether that's a physical wire connection or a satellite connection or a mobile cell tower connection between two endpoints in order for your information to go from your computer to wherever the website is hosted. Okay, and then we sort of zooming in closer and you obviously get local infrastructure, and then what you'll have is basically a bunch of data centers. So this is a building here that stores a data center inside of it. Okay, this particular one's often called a co-location data center, but we don't need to worry about why that is. But essentially what's stored inside of it is a bunch of networking technology and a bunch of computer hardware. So we zoom in even further, okay, and this is what one of the Google data centers looks like inside. Okay, and these are actually just rows upon rows upon rows, okay, of sort of efficiently, physically spaced computers with servers running on them. Okay, and these might not necessarily all be web servers. Okay, they might have other things, but some of them definitely are going to be web servers, which are running software which stores the websites that you will be hosting. Okay, this is actually a cooling plant for that particular data center, so you can see how much. I mean, this is the other side of that equation of all that content, is all the hardware and all of the infrastructure and even just cooling that needs to happen for all the heat that's generated. Okay, so these things actually physically exist and they take up a lot of space and a lot of resources. Zooming in even further, this is a look at racks. Server racks. Okay, so often they're sort of separated into these modular towers, which then have computers sort of laid into them in such a way that someone can get in there if there's something wrong, hardware needs fixing. They're reasonably easily accessible. Okay, and then we zoom in even further. There's a single rack on the left, and on the right there, all the way zoomed in, those sort of three horizontal line looking things, okay, they're three server computers. Okay, they don't need displays because no one ever really interacts visually with them. Okay, but so that they're known as rack mounted servers. They're simply just a computer that's designed physically in such a way to be able to stack neatly into a rack like that. Okay, but the important thing to understand is that they're just computers. Okay, they're just computers, like my laptop's a computer, like your computers are computers. You could create a server out of any computer that you have. Okay, the fact that they're stored this way is just a matter of economies of scale. Okay, this is the most efficient way of storing lots of servers in a defined amount of space. Okay, so that's what the computer that your website will likely physically look like that your website is going to be hosted on. Okay, but then we need to look at, well, how does the information actually get from, so once you've got your website hosted, how does the information actually get from my computer when I'm requesting your website all the way to the server and all the way back? Okay, and again, I don't expect that you need to remember any of this stuff in super detail, but I think an understanding of what's actually going on from an information level now will make it a bit easier to understand how and why we're implementing the dynamic web technologies. So I found a nice little YouTube video that I'm going to use to illustrate this point, because it does it as well as I could.
Whenever most people think of the internet, this is what comes to mind. The internet is not a bubble cloud, even in the new age of cloud computing. The whole fuzzy cloud picture was created by people more concerned about job security than education. This is the internet. The internet is a wire, actually buried in the ground. It might be fiber optics, copper, or occasionally beamed to satellites or through cell phone networks. But the internet is simply a wire. The internet is useful because two computers connected directly to this wire can communicate. A server is a special computer connected directly to the internet, and web pages are files on that server's hard drive. Every server has a unique Internet Protocol address, or IP address. Just like a postal address, IP addresses help computers find each other. But since 72.14.205.100 it doesn't exactly roll off the tongue, we also give them names like Google.com, Facebook.com, or SecurityCatalyst.com. So this is how it works. Your computer at home is not a server because it's not connected directly to the internet. Computers you and I use every day are called clients because they're connected indirectly to the internet through an internet service provider. Here we'll pretend that this is my home laptop and I'm using DSL. Now let's pretend that I want to visit AOL.com, which is coincidentally both a server and an ISP. I hop onto my laptop with DSL, go through my ISP onto the internet, and look at AOL.com. My computer connects with AOL.com, and I can look at its web pages. Now, let's say that I want to send an email to Aunt Ruth. Aunt Ruth has AOL dial-up from home, and I've got a Gmail account. I log on to gmail.com and compose a message to Aunt Ruth's email address, auntruth@aol.com. Once I click send, gmail.com sends the email to AOL.com. The next day, Aunt Ruth dials into AOL servers and retrieves the email. Whenever an email, picture, or web page travels across the internet, computers break the information into smaller pieces called packets. When information reaches its destination, the packets are reassembled in their original order to make a picture, email, web page, or tweet. Okay, so imagine you're at work sitting next to your boss, and you're both surfing online. Your boss is doing market research, and you're updating your Facebook profile. You're both sending packets back and forth over the internet. But what's to keep your packets from accidentally ending up on your boss's screen? That could be embarrassing. The solution to that problem is IP addresses and routers. Everything connected directly or indirectly to the internet has an IP address. Everything. That includes your computer, servers, cell phones, and all of the equipment in between. Anywhere two or more parts of the internet intersect, there's a piece of equipment called a router. Routers direct your packets around the internet, helping each packet get one step closer to its destination. Every time you visit a website, upwards of 10 to 15 routers may help your packets find their way to and from your computer. Imagine each packet as a piece of candy wrapped in several layers. The first layer is your computer's IP address. Your computer sends the packet to the first router, which adds its own IP address. Each time the packet reaches a new router, another layer is added until it reaches the server. Then, when the server sends back information, it creates packets with an identical wrapping. As the packet makes its way over the internet back to your computer, each router unwraps a layer to discover where to send the packet next until it reaches your computer and not your boss's. And that's how the internet works, in 5 minutes or less.
Okay, so that's sort of what's going on at an information level. And so a few things to pull out of that is, well, first of all, the concept of an IP address. So as I said in the video, an IP address is essentially like a postal address for things that are on the internet. And every single device that's connected to the internet has an IP address. Okay, if your phone's connected to the internet, it's got an IP address. Your router, your computer, and all of the other points in between where packets are going to be directed around the internet. So the only reason that we have domain names is because they're easier to remember than a bunch of numbers. Okay, but really the thing that's actually directing traffic around the internet is going to be the IP address. Okay, the domain name, the very first thing that happens when you put a domain name, a URL into a web browser, is it will connect to a special type of server called a domain name server, or a DNS, and it will simply look up a table that says this is the domain name that they're looking for, and that server will have the IP address of that domain name. Okay, and then from that point forward it will use the IP address. So you can actually find the IP address of any web address by using a command line utility called ping, okay, which simply just sends packets of data, random packets of data to a particular address to ensure that connection can actually go back and forth. So this is a screenshot from me doing exactly that. So I'm pinging google.com, okay, and I can see that the IP address here is 74.125.237.201. Okay, and if I was to type that into a web browser, remember it correctly, 227.201. Okay, that will actually take me to that address. Okay, so you can see you can actually navigate around the internet without using domain names at all. Okay, if you could remember the IP addresses of the websites that you want, like people used to actually remember phone numbers, then you could just type those in. Okay, so now this is a screenshot of using another command line utility called traceroute, again of google.com. Okay, and this utility will actually show you. So again, if you remember back to the video, it said it will go through, I think they said 10 to 15, but it will go through a number of different routers. And a router is any device that's going to direct your internet traffic further on. So the first point of contact might be the wireless router that you have, and then it might be your internet modem, and then it might be your ISP's various routers, okay, and then so on and so forth until it actually reaches the web server that's hosting the site that you're looking for. Okay, so this output here from the traceroute command for google.com is actually showing exactly that. Okay, so it actually, my request passes through 15 different routers before it actually gets to google.com. And the fact that it happens in milliseconds each time means that it gets back, and it seems like it happens in one quick step. So it's quite interesting. I mean, a lot of time we complain about how slow the internet is, but considering how far it has to go and through how many different interfaces, we should probably be asking why is it so fast. So it's quite interesting that it can actually operate so quickly across such a vast distance, and also through so many different interfaces. So I can tell here actually that these first two. So I did this from home last night. This first one, I can tell that first IP address, because I know I set it up, is my Wi-Fi router, and then that connects downstairs to my cable modem. Okay, and that will be the address of the next one, and then it goes through here. These are going to be, I guess just various routers throughout the network in order to get to my ISP. Okay, and then if you look down here, you can see there's a bunch of Telstra ones. Okay, my ISP is Telstra cable, so it makes sense that it's going through their routers. And then finally, you can assume that these last few are the extra steps that it needs to go through and actually access the Google server. Okay, whichever of Google's web servers is hosting their website. Okay, so fortunately, from both an end user's point of view and also from our point of view as web developers, we're not network programmers. Fortunately for us, all of the internet protocols in the Internet Protocol Suite that we sort of briefly looked at last week take care of all of this stuff that's going on under the hood for us. Okay, so while what's really going on looks something more like this, okay, being passed between protocols down through hardware, up through protocols to the application, okay, via these protocol stacks. Okay, we can actually sort of look at the process. We can abstract it for our purposes to essentially our client computer interacting with the server computer, okay, in a straight line. Okay, so we can abstract it essentially from this to this. Okay, so I mean, I have just sort of detailed a little bit what's going on underneath, and now I'm saying you can ignore that. But I think knowing that now makes it a little bit easier to, even if you now look at what's going on as if it's like this diagram, understanding what's going on underneath, I think helps us still appreciate why we need to do certain things. Okay, but we can, for all intents and purposes, when we're developing websites, we can think of essentially the client which connects through the internet, through a bunch of stuff going on, ultimately to a web server. Okay, and as represented by this diagram, generally a server will serve multiple different clients. Okay, so every one of us in this room now could go and access google.com. Okay, so we've got multiple client computers, and they would all go and access that same, in theory, that same server computer that's hosting the Google website. Okay, so with all of that in mind, the reason that I went through that is because to understand, the first thing to understand about dynamic websites is how the operation of what's going on behind the scenes there actually differs. Okay, and this diagram demonstrates it fairly well. So on the left here we've got the client-server model for a static website, and on the right we've got the client-server model for a dynamic website. So this top half here represents what's going on the client, okay, or your computer, and this bottom half represents what's going on the web server. And the thing I want you to notice is that, again, on the client side, nothing really changes. Okay, a request is made to the web server, some stuff goes on the web server, and HTML is returned. Okay, so the important difference is what's going on the web server. In the case of the static web page, okay, it's very simple. You're making an HTTP request, okay, and based on the URL or the URI, okay, that's how it knows what file you want to actually access on the web server's hard drive. Okay, and so it has something which will translate the URL to go and point to a particular file, and then it will send that HTML file back to you. Okay, so it's a very simple sort of dumb logic that the server has. Okay, it just goes, okay, you want this file, there it is. On the dynamic website, what's going on the server is a little bit more complicated. Again, you make the request, and there's URI detection, but instead of storing a single page as a single file on the web server, in the case of a dynamic website, what you're usually doing is the first point of call is interacting with a script or a program. Okay, and then that program usually will assemble, again based on the URL, it will assemble content from various different sources. It may pull different files together, or more commonly it will actually go and pull data that's stored in a database out and combine all those things together, do whatever other logic is within that server script, and then finally send that all combined back to the web browser as HTML. Okay, and I'm going to reiterate this point sort of over and over again, is the other important thing to notice is that by the time it leaves the server, okay, it still just looks like HTML. Okay, so it effectively looks the same, and this is why it's hard to tell whether you're looking at a dynamic website or a static website, is because everything that happens differently happens on the server. By the time it's sending content back to you, it still just looks like a single HTML page. Okay, but we'll go into that in more detail. So I guess we should talk a little bit about this HTTP request thing. Okay, so again, this is from a software and a protocol level, a little bit about what's going on behind the scenes. Again, I don't expect that you need to remember this in any great detail, but it just helps a little bit to know what's going on. So HTTP, or the Hypertext Transfer Protocol, functions as a request-response protocol in the client-server computing model. In the most common example, the web browser is the client and an application running on a computer hosting the website is the server. Okay, makes sense. The client submits an HTTP request message to the server, and then the server returns a response message to the client containing completion status information about the request, and may also contain requested content in its message. Okay, so this is a diagram that essentially just indicates what's going on there. So there's actually a few different steps to this. It's not just sort of a sort of call and response thing. There's a few things going on in between there, but the details of that are not necessarily that important. But I did want to show you what an HTTP request and response actually looks like, because this is another one of the things that's sort of hidden when we're browsing websites in a web browser. Okay, a lot of this stuff, I mean, the web browser is designed to take the HTTP response from the server and display it as a web page. But you can actually make an HTTP response in the command line as well, and you can see what comes back is actually a little bit more than what ends up being displayed in the window as a web browser. So this is a screenshot of an HTTP request to the Wikipedia website, and you see it's highlighted various different areas. The part that we would be used to seeing in the web browser when we view the source is this response body down here. Okay, if you can read that, you can see it starts with doctype HTML, and then it's got some HTML content in there. But what I want you to realize is that there's actually other parts to this. So there's the request here, okay, that's what's being sent, but the first part of the response includes something called a response header. Okay, and this is actually what contains a bunch of information from the server indicating various different things that are useful to the web browser. Okay, and I won't bother detailing what all of those different things are, but one of them which you might be familiar with is the HTTP status codes. So if you've ever gotten a 404 error message, okay, that the page cannot be found, okay, how does the web browser know that that's what the server said to it? Okay, well, that's actually information that's contained within the HTTP response header. If you can read this very first line here, it says HTTP/1.0 200 OK. Okay, so that 200 is the response code, like 404 is the code for a resource not found. 200 is the response for OK, everything worked, here's your content. Okay, and this becomes important in later on in when we're looking at scripting as well, because we can take advantage of these HTTP headers to actually send information to the web server as part of the HTTP request and get information back that's not necessarily part of the content we want to display in the response headers. Okay, so again, don't necessarily worry about remembering all of this, but just know that there's more to what's being sent back from the web server when you make a request than what's just being shown in the web browser page. Okay, so this slide's all about what the software actually looks like that's running on a web server. Okay, so this diagram here again is split into client and server. The client in our case generally is usually a web browser. Okay, but the side I'm interested in here is the right hand side, the server side. So this diagram represents what we call the LAMP architecture, which is the most common but not the only web server stack. So it's a series of different programs that's commonly implemented on a web server for dynamic websites. So the so LAMP there is an acronym, and each letter stands for one of the bits of software that runs on this particular type of web server. So the L stands for Linux, the A stands for Apache. Okay, Apache is the web server software. It's the thing that takes in the HTTP requests and sends back out the HTTP responses. The M stands for MySQL, okay, which is a common database implementation, and the P stands for PHP, which is a very common dynamic scripting language, server-side scripting language. Okay, and it's the P part of this that we're going to be most interested in this unit. Okay, we're not going to really deal too much with messing around with databases. I mean, we will use them, but a lot of that stuff will be taken care for us. We're not really concerned with what the web server is doing. We just need to know that it's working okay. It's taking in information and sending it back out. Okay, but all of the goodness that goes on in allowing us to create dynamic websites, okay, which respond to things dynamically, is done in this layer. Okay, the PHP layer. Okay, so now maybe we should just revisit, okay, or summarize the differences between the static website and the dynamic website. So the static website, as I did mention with that diagram before, each logical page is represented by a physical file on the web server. Okay, so one page, you request a page, it's an HTML file on the web server, it gets sent to you and displayed in the browser. Okay, there are some advantages of static websites. Okay, the most obvious one for you guys is going to be that there's a lower entry barrier for development. Okay, it's just plain old HTML and CSS. That's why we teach it first. Okay, because, I mean, I guess the good thing about creating dynamic websites is you don't have to just suddenly throw away everything you've learnt about static websites. You still use the same HTML and CSS, you just add another layer on top of that in PHP. Okay, some other advantages: the hosting requirements are usually very simple, they're easily cacheable, and they can be viewed offline. Okay, you can view, as I'm sure you know, you can open up an HTML file in the web browser and view its contents. You can't do that with a PHP file. It actually needs the web server software to run and interpret that code. But I'll reiterate that again a little bit later. And the disadvantages of static websites, okay, should be obvious by now. We've gone over them. Okay, there's much less scope for personalization and interactivity, and every little change update needs to be done manually. Okay, and in the current environment where there's so much content, so many users, okay, that just doesn't cut it in most cases. Okay, that sort of reiterates what I was talking about before. All right, so the dynamic website. Again, as I said before, but it's worth reiterating, the website content is stored in a database and or other external sources and assembled along with markup and output by a web server script or application. Okay, and the advantages of dynamic websites are that content can be updated in a decentralized way. Okay, so a single webmaster no longer has to have the sole privilege or responsibility of updating the website. Modularization is a big one, which I'll explain a bit more later, and reuse of common code. Okay, so this solves the issue that we were talking about before, whereby if we have that 10-page website, we have to go and we change the menu, we have to go and change it across every page. Okay, what we can do is split up the design of that page into little modular bits, okay, and essentially have one file that represents the header, a file that represents the menu, a file that represents the content, a file that represents the footer, and in any page that we need them, we simply just include those with one line of code. Okay, and so anytime we need to go and change the menu now, we just go and change that one menu file, and it's automatically included in any other pages that we need it to be. All right, and I'll explain that also in more detail later on, and in the tutorials as well. Okay, and obviously automation, again, as we said before, is a big one. Okay, so some of the disadvantages of dynamic websites, again, will probably be obvious. For our purposes, as people are actually making these, yes, it does take more effort to implement a dynamic website. There's more technologies to get your head around. How they interact's a bit more complicated. But we do this, I mean, we take on this extra burden, I guess, if you want to call it that, such that the experience for the end user is better. Okay, and it's not even, as I said before, it's not even in this day and age, it's not even just a case of better, it's the only way of really doing it. There are more complex web server requirements, and traditionally have been issues with pages being indexed by search engines, but that's not really an issue anymore. But the thing to note is that overall the benefits will almost always outweigh the disadvantages. Okay, and that might be something that you disagree with when you start getting into it, and if it seems difficult or seems like a lot of work, you might not appreciate the payoff yet. But I guarantee as you use it more and as you work on bigger websites, you will see the payoff. Okay, now in terms of actually having a web server to develop your website on, okay, because as I said before, we can't just now write the HTML page, load that into a browser and see what's going on. We actually need web server software running in order to execute our dynamic script, our PHP code. So there's a few different options for this. You can actually install a web server locally on your own computer. When I said before that any computer can be made into a server, it's absolutely true. All you have to do is install the server software on it. Okay, and in terms of the AMP server model, the Apache MySQL PHP, all of that server software is open source and free. Okay, so you can install it on your computer, and you could install those bits of software individually and configure them all. But an easier way to do it is to use pre-packaged bundles of this stuff. Okay, and so a common one is MAMP for OS X. Okay, it should be obvious, these are just the Mac and Windows equivalents of the LAMP architecture. So all we're doing is replacing that first letter, the operating system on which it runs, from Linux to Mac OS to Windows. And then the other three parts of the equation are all the same. So there's links there to those if you want to install those and run a local web server on your computer. I actually have it running right here on mine. Okay, so this is what it looks like, and then you can see I've got a bunch of servers defined that I can type into my web browser and go and look at those. Okay, so it is quite easy to run a local web server on your own computer. Obviously, other people aren't going to be able to browse your website unless your computer's connected to the internet and you've allowed incoming connections access to your web server. Okay, so we don't usually do this sort of thing in order to actually publish the final thing, but it can be a quicker way of developing our application because we don't have to go and transfer it to our remote web server, our files to the remote web server every time we want to make a change. So there's links there, and if you're interested in this, by all means you don't have to worry about installing local web servers, but if you want to speed up your development process a little bit, those links will explain what you need to do in order to set them up. Okay, there's the QUT web server, which again will just be a server that exists somewhere in QUT, a computer with web server software running on it. And as students of QUT, you all have accounts on this web server. Okay, and that lives at webhost.ci.qut.edu.au. Okay, so that's another example of a web server. Oops. Okay, and if you have a remote web server, that is one that's not running on your local machine, then you obviously need a way of transferring files from your computer to the remote web server. And the way that we do that is with FTP, or the File Transfer Protocol. Okay, and that's simply just a way of doing exactly that, transferring files between computers across a network. So what you'll need is a bit of software called an FTP client, which you may already be familiar with. But essentially what it is it's equivalent to is equivalent to like the Mac Finder window or the Windows Explorer window. It's basically a file browser, but rather than transferring files between different places on your hard drive, you're transferring files between two different computers across a network. So in order to do that so that not just anyone can transfer files to your web server, you do need some login details. Okay, so in the case of the QUT one, it'll be the ones that are illustrated here in this image. Okay, so there'll always be three things that you need. There'll be a host, there'll be a username, and there'll be a password. Okay, so the host is either the IP address of the domain, which points to where the web server lives, and then a username and password representing an account. Okay, and as I and hopefully Cassie mentioned in the tutorials, we don't actually recommend that you use the QUT web server for your portfolio. Okay, for a few different reasons. The fact that a QUT login is required to view your site, and once you leave QUT, you'll want to migrate it to your own web server anyway, which is possible, but it's an extra step, an extra hassle. You don't have access to configure the web server, which you may need, and the security is quite locked down, and if you have your own web hosting, then tech support is probably going to respond a lot quicker. Okay, but I don't really need to reiterate that too much. The next few slides, again, really go over content that was in the tutorials from last week about web hosting and domain name registration. So I won't necessarily go through these again, but it may make more sense now that you've sort of seen that what's going on behind the scenes, what it actually is that you're paying for. So I won't necessarily go through all of these. This information is duplicated in the tutorial post from this week's tutorials. And you can read through that. You can read through that information on the lecture slides. I'll upload those. But I'll move on now to something that's probably a little bit more important, which is finally we get around to talking about the thing that we're actually going to use, okay, and what we're actually going to look at in the tutorials, and that is PHP. Okay, so PHP is a popular server-side scripting language, and it's what we use to program the dynamic logic into our website. Okay, so in these diagrams that I have shown previously, okay, I've circled the part which is PHP in each of these. Okay, so it's essentially the part where we program the brain of the website. It does the thinking. Okay, it does the intelligent stuff on our website. Okay, so there's a few things to know about developing PHP. The first is that PHP files have the extension .php, probably unsurprisingly. And as I said before, but again I need to reiterate, because PHP code has to be executed on the web server, you can't simply just open up a PHP file in a web browser and expect to see the content. If you do that, what's going to happen is the browser will probably just automatically re-download that PHP file for you. Okay, and that's because the browser doesn't have the software in it to interpret the code, the PHP code, and do anything with it. Okay, so the best it's going to be able to do is give you the HTML code and just ignore the PHP code. So you actually need to, when you're developing, you actually need to make sure that you write the code and then you save the file and make sure it's on a web server running the Apache MySQL PHP software, and then view that in the web browser, and it will, and then it will, the PHP code will actually execute, and you will see the result. Okay, so the next few slides, there's a fair bit of content and examples in these, but again, don't freak out about worrying about remembering any of this stuff. This is the stuff that we're going to go over in more detail in the tutorials, but I'll mention it. I'll mention a bunch of this stuff first to save a little bit of time in the tutorials, but also just to give you a sort of overview. So PHP is commonly written interspersed with HTML. Okay, like this example here, and the way that we tell the way that we tell the PHP interpreter which parts of our code should be interpreted as PHP is we use opening and closing tags. Okay, just like in HTML we use opening and closing tags to say this is a heading or this is a paragraph, or in JavaScript we surround things with script tags. Okay, anytime we write PHP, it has to be surrounded in, well, it has to open with this tag here, okay, which is angle bracket question mark PHP. Okay, then we write one or more statements of PHP, and then we close it with question mark angle bracket like that. Okay, and you could write PHP. It's the same as HTML. Okay, you could write this all across one line, or you could write it on multiple lines. It doesn't care about how you split up the code on different lines. All it cares is that you have the PHP code surrounded by those opening and closing PHP tags. Okay, this is probably the biggest logical step to understand in terms of using PHP. And it's not hard to understand, but it's sometimes difficult to appreciate that it's going on, again, because it's difficult from an end user point of view to see that it's any different from a static website. Okay, but it's very important to realize that the processing of the PHP code all gets done on the web server. Okay, the response back to the client browser will only contain HTML. So this image here is a screenshot of this code here being executed on the web server. Okay, so this just has one PHP statement here. Okay, it uses this statement echo, which basically says output whatever follows that into the HTML document. Echo hello world. Okay, and then when we look at that page in the web browser and I view the source, what I want you to notice is that there's no PHP code here. Okay, by the time it gets delivered back to the browser, it's just HTML. So that processing of that echo hello world statement has happened on the web server and then been injected into the HTML page essentially, and then sent back to the client. So all the client ever sees is the result of that output. Okay, so that's probably, as I said, the biggest logical or the first logical hurdle to get over, is to understand that the PHP processing all happens on the server. That's why we call it a server-side language. Okay, and the flip side of that, JavaScript, which you may have some familiarity with, is a client-side scripting language. So if we have JavaScript in our HTML file, that will actually get sent along with the HTML to the web browser. It doesn't get executed on the server. So if you view the source of a HTML file that contains JavaScript in it, you'll be able to see the JavaScript code, because it's the web browser itself that executes that JavaScript code. Okay, and so that's the difference. That's why we have two different sides of these. Okay, the server-side scripting and the client-side scripting. And you might ask, why do we need those two different sides of things? Well, you can imagine how insecure it might be if you had to have sensitive code that contained usernames and passwords and stuff, and that was all in JavaScript, and that got sent along to the browser. You can imagine how easy it would be for someone to go through and discover all that sensitive information. Okay, so we have server-side scripting languages so that can all happen before the result gets sent back to the client, and we can keep any of that information essentially secret. Okay, so some of the language features of PHP, if you're at all familiar with any other coding or scripting languages like JavaScript, then a lot of what we do in PHP should seem somewhat familiar. Okay, so it has features such as comments, okay, both single line and multi-line comments. So this is an example here of writing a single line comment and a multi-line comment. Okay, and the concept of variables. Okay, so variables is how we store bits of information. The big difference between PHP and a lot of other programming languages is that when we're declaring a variable in PHP, or when we're declaring it, say for example in JavaScript, we'll use the keyword var to say that what we're putting next is going to be a variable. In PHP, we don't use the var keyword. all we have to do is make sure that when we're referring to a variable, we start the variable name with a $sign. So that's how PHP knows that you're referring to a variable. Okay, so this, for example, here declares 4 different variables with different information in them. We've got arithmetic operators, okay, stuff that allows us to do sums. So we've got the plus, minus, multiplication, division, and modulus operator. The modulus operator is just one that allows us to return the remainder of a division. Okay, but it's worth noting that there's a special case again in PHP when we're looking at the concatenation operator. So when I say the concatenation operator, concatenation means joining 2 strings together. So if we do that in JavaScript, we have quotes, some text string, quotes, and then another text string, and we join those together with the plus symbol. In PHP, it doesn't use the plus symbol for joining strings together. Okay, it uses the full stop symbol. Okay, so in this example here, if I was to join these two variables, first name and last name, with a blank space in between, okay, I use the full stop character here in order to join these together. Okay, so that's a common cause of errors is you, especially when you're jumping back and forward between, say, JavaScript and PHP, is you'll forget that in PHP to join strings together you need to use the full stop. Okay, simple but easy to forget. We've got functions. Okay, so functions are where we define repeatable bits of code which we can call over and over again. Okay, so again, here's an example here, a function which prints out my name, and every time I call it, it will do that again. Okay, so so the whole idea of that is we don't have to create that code each time we want to perform that function. We create a function that does something, and we call it as many times as we need to. Okay, again, don't worry about it too much. We'll go over it more on the tutorials. PHP, like most programming languages, has a bunch of built-in functions that do various different things. Okay, and the way you find out what those functions are and what they do is by looking at the PHP documentation, which exists at the URL, which I've outlined there, php.net/docs.php. So, interestingly enough, the PHP website's programmed in PHP. Makes sense. And that's a screenshot of what the documentation will look like for a particular function. So this, for example, is the round function, which simply takes a number value and will round it to the nearest whole number. Okay, so a very simple function. So it has all these built-in functions, so if you want that functionality, that common functionality, you don't have to go and create it yourself. We've got conditional statements. Okay, so it's usually an if statement, and they look pretty much the same as they would look in JavaScript or other languages. Okay, if some condition, do something, else if some other condition, do something else. Okay, so this is the first level of non-static logic that we can have. We can have one or more different situations and respond to those in different ways. And that's something we can't do with just a static web page. We've got arrays, which are simply just lists of items. A slightly different way of defining an array in PHP than with something like JavaScript. But there's an example of how you do it here. Essentially, you call a function called array and then pass it the items that you want to then exist in the array. Okay, and then referring to an element in the array is pretty much the same. We've got loop constructs, which allow us to execute one or more statements a given number of times. Okay, again, we'll go through that in more detail. So pretty much all of the features that are common to most programming languages, PHP has. Okay, and it can do all sorts of stuff. You can read files and write files with it. Okay, it's a fully fledged programming language. There's not much that you can't do with it. So in addition to these, PHP, another important thing that PHP does, which is sort of its specialty, which you might not be used to with other programming languages, or might work in a slightly different way, is that it can take in and process information sent by the client. Okay, so one of the ways that we do that is with something called get parameters. So you might have, when you're browsing the internet, you might have seen something that a URL that looks something like this. Okay, it'll have the address of the website, and then it will have extra stuff on the end that looks like a bunch of values. And that's exactly what they are. They're a bunch of values that in this case are being sent along with the request for a particular web page to the web server. Okay, and so one way of doing this is using what's called get parameters. So get parameters can be sent to the server as an addition to the URL, and this addition is known as the query string. Okay, so that's basically everything that comes after the end of the file name here. This part here is the query string. And what it is just a series of what we call name value pairs. Okay, so we have title equals main page and action equals raw. So if we were to send this request with that query string along to the PHP file running on the Wikipedia website, then that PHP file would be able to access this information using a special array that's built into PHP called $_ in all capitals get. Okay, and so we would be able to access the value of title by get title. So the array item get title would contain, in this case, the value main page, and the array item get action would contain the value raw. Okay, so that's the simplest way of sending along simple text-based data to our website. Okay, and PHP can handle that and then do whatever you want with it. Okay, maybe you're sending along a username. Okay, you send along a username and then it uses that to print out on the page. Very simple, but that's something you could do. A lot of the time you'll see, in the case of Google, okay, if you're doing a Google search, that's how it sends the text that you put into that Google search text field to the web server so it knows what you want to search for. Okay, and there's other special arrays that exist in PHP to store various input data. There's the $_post array, which is very similar to get, but rather than sending the information and tacked onto the end of the URL, it's actually sent along as part of the HTTP request header. Okay, so that thing I showed you before on the command line of doing the HTTP request, and it had the body, but then those extra bits. Okay, there's those extra bits that it's using to send data along with the request to the web page, and in some cases return it there as well. Okay, and then there's one called $_files, which anytime you have a file upload form, okay, that will store references to those files that have been uploaded. We've also got something called session variables. Okay, so another thing that PHP can do that just static web pages won't allow you to do is remember information across different web pages. Okay, so you might have come across the situation where you're creating sort of like a web application, and you want to. And the user needs to navigate between multiple pages, but you want to remember information from the first page. Maybe you get them to type in their name, for example, and you want to use that to output on another page. But as soon as you navigate away, in the browser, I mean, unless you use something like cookies or local storage, then that information is lost. It's not retrievable. So PHP allows this idea of having sessions whereby each time a user comes to the website, okay, it knows that that's the same user visiting the website each time it goes to a different page. You can actually store session variables that will be maintained across any page that they visit on that website. Okay, and in order to access that, we use another special array. In this case, it's called $_session. Okay, and you can read more about sessions at this link here. We probably won't use them that much in this unit, but they're a very useful thing to have. And if you ever have a web project whereby you need to maintain information across pages like that, then session variables are the things that you want to use for that. Is there a question?
Yeah, so is it just like a cookie on the server side?
It implements it in different ways. Essentially, it's on the server side. It's I mean, as I say here, it's an array. Okay, it stores it as a bit of information, but it does use cookies, or can use cookies on the client side, or information sent in the header, in order for the client to identify that it's the same person that's accessed it as the time before, if that makes sense. Because when you're making an HTTP request, it's not a consistent connection. It's not like creating what's called a socket connection, whereby you connect to the server and the connection remains open until you leave. Okay, every time you make a request, the response is set and then the connection's cut. So it does need something to send back and forth in order to say, hey, I'm the same person who just accessed that web page a little moment ago from this IP address. Yeah. But in terms of how it's stored on the side of PHP, it's just stored as a variable in the PHP program. Okay, PHP supports modularization. Okay, so if we again remember back to the example of editing the main menu across multiple different pages, okay, where it becomes a hassle to modify the menu because we have to do it on every single different page. PHP helps us solve this redundancy by allowing us to modularize our code. Modularize just means split it up into reusable chunks. Okay, so we could, for example, split the header, footer, sidebar, menu, whatever else. Whatever is a repeatable section of code across multiple pages, we can pull that out, put it in its own file, and then in any other page that we need them, simply just include those files. And then when we need to go and change the header, or change the menu, or change the footer, we're just editing one file instead of every single file. Okay, and the way we do that in PHP is by using the require or the include PHP statements. Okay, they do pretty much the same thing. And these diagrams here are actually found on a French website, so some of the text is in French, but it doesn't matter. The concept is what's important here. So this is what's going on essentially when we have when we're doing exactly that. So we can imagine 3 different PHP files here which represent 3 different pages. Okay, so we've got an index page, I think this is a products page, and a contact page. Okay, and rather than having the HTML code for the header and the footer in each of these, we split it off into a header.html, a footer.html, and then to include these we simply just have one line of PHP for each one. So require header.html, require footer.html in each of these. Okay, so when it comes time to changing that header, which may have the menu in it, I just go into the header.html file, make my changes there once, and then it's automatically included whenever someone accesses one of these 3 files. Okay, and the resultant output on here looks like this. So there's if this is the index page, there'd be whatever's in the index PHP page, and then the content. Essentially, what's going on is if you were to redo this process manually, it would be saying wherever I have this require statement, go and find that file, do a select all, copy it, and paste it in there. Okay, so that's pretty much exactly what it's doing. And then the final output is the combination of whatever is in this index file plus whatever is in the files that it's included or required. Okay, and then the last thing really that I want to talk about, the last feature, the last thing that PHP allows us to do is separate our content from our markup. So as we've been going along through the various different web projects that you've been doing, you've already hopefully seen the benefits of separating things out from each other. Okay, the first one we probably came across was separating our structure from our style. Okay, so the benefits of having our CSS in a separate file versus having them inline on each of the elements. Okay, it makes it again much easier to update the CSS if we're just doing it in one place rather than across every single file. So PHP allows us to extend this concept a little bit further by actually taking the text content out of the HTML page and just having the structure. Okay, so what this means is that, say for example, we have 10 pages that essentially have the same layout. They're a header, they've got a header, sidebar, footer, and a content area. And all that really changes across those 10 pages is the content that's within that content section. Okay, so again, if we were to do it statically, we need to duplicate this page and then modify the content section. And then when it comes to changing it, again, it's a hassle. Okay, if we use PHP, again, in combination with using that idea of modularization, okay, splitting this off into different parts, we can also take advantage that we can interact with the database by taking that content part, so let's just say it's even text, putting it in a database and then creating one template file for those 10 pages, okay, that has all of the HTML markup, all of the CSS, whatever, but then when it comes to that section where the content is meant to go, all we need to do is make a call to the database and inject the content that's appropriate for that page. Okay, and that page is usually indicated by something like a get parameter. Okay, so you'll have like a page ID equals this, or a page name equals this, and then you'll have a little bit of PHP that goes, go and find the content for this page and inject it into this part of the markup here. Okay, and so that way we have the concept of templating. We can have the one page which represents any number of actual, you know, sort of static pages that we might have created. Okay, and this is essentially exactly what we're doing when we're creating a WordPress theme. So again, don't worry about what any of this does for now, but what I want you to sort of notice about this file here, and WordPress themes are created in PHP, what I want you to notice about this file is that there's very little content in here that is like images or paragraphs of text. Pretty much all of the content in here is either HTML markup, okay, or it's PHP code. Okay, so all this is doing is providing a structure for whatever this page is going to look like, and then the PHP code to insert whatever content is relevant for whatever resource is being accessed. Okay, in terms of WordPress, that's going to end up being things like you're going to have, let's say, have a bunch of different pages or a bunch of different posts. Okay, when we click on a post, they're different posts because they have different content, but they all essentially look the same aside from that content. So rather than creating a separate HTML file for each of those posts, we create one template file and then we store the content in the database, and based on what the URL says, we go and access the content that's relevant to whatever page the client is actually requesting. Okay, so this will make a lot more sense when we actually get around to doing this, so don't worry too much if it doesn't make that much sense now. Okay, so there is one final sort of aside that I want to talk about, and so I've mentioned the fact that JavaScript is a client-side scripting language, but it does have a role to play actually in making dynamic websites, and that is through AJAX. So AJAX stands for Asynchronous JavaScript and XML, which is sort of totally irrelevant. It's sort of even a wrong name. But it's a technique for allowing a client-side language like JavaScript to interact with a server-side language like PHP. Okay, so, and the upshot of this is that we can create asynchronous web applications, and that's a fancy way of basically saying that we can update the content of a web page without refreshing that page itself. Okay, and I'm sure you've seen this. I'm sure you've seen this happen a lot. If, for example, you're on Facebook, okay, and you create a post, you type in the post, you hit submit, you'll notice that that page is not refreshing, which is what you would normally have to do in order to send information to the browser and then receive another response. So what's going on there is, behind the scenes, JavaScript is actually taking the place of the web browser for a moment and performing that HTTP request on the web browser's behalf, getting the response back, and then injecting that response into the web page. Okay, so again, we probably won't be doing much with that in this unit, but it's something that people often ask about and don't quite understand what Ajax is and exactly what it does. But essentially, that's what it is. It's a client-side scripting language like JavaScript, interacting with a dynamic web server, and then usually getting a response and updating the page without having to refresh that page. And it just creates sort of a more seamless user experience. Okay, and this is just a diagram of what that looks like. So it looks much like a request that a browser would make, and that's because it sort of is. It's doing exactly what the browser does, but not refreshing the page. Okay, and that's the end of my lecture.